As the next step, we are going to write the total energy. So total energy is equal to kinetic energy plus potential energy. Okay. So kinetic energy plus potential energy will be our total energy E. That is E is equal to half mv square plus capital V. Kinetic energy is half mv square and potential energy is equal to capital V. Or we can write E is equal to P square by 2m plus V. Kinetic energy can be written as P square by 2m. If you have any doubt, you can look here. P square by 2m is equal to P square is equal to mass into velocity, right? So P square is equal to m square V square divided by 2m. Mm can be cancelled, so that we will obtain half mv square. So instead of half mv square, we can write P square by 2m. So E is equal to P square by 2m plus V. Okay. Now multiplying this equation by psi. That is E into psi, E psi, which is equal to this term into psi, that is P square by 2m plus V into psi. Or E psi can be written as E psi is equal to H psi, where H is equal to P square by 2m plus capital V. Okay, so I am substituting this P square by 2m as H, which is known as Hamiltonian operator. Is very important. Hamiltonian operator is equal to P square by 2m plus V. That is kinetic energy plus potential energy is known as Hamiltonian operator. So that E psi is equal to H psi. This is equation number 5. Now we are starting from this equation. Equation number 4 can be written as E psi is equal to psi can be taken to the inside of this bracket, right? So P square by 2m into psi plus V into psi. Psi into this term plus psi into this term. P square by psi by 2m plus V psi. So I will split these two terms into 2, that is E psi is equal to P square by psi by 2m plus V psi. Now we are going to substitute for E and P square. We have already E, energy operator is equal to IH cross dou by dou T, and momentum operator is equal to minus IH cross dou by dou X. These two equations are very important, energy operator and momentum operator. Similarly, our Hamiltonian operator. Then that is E is equal to, we have this equation, P is equal to, we have this equation. So instead of E, we are going to substitute IH cross dou by dou T. Then we have to substitute for P square. What is P? Minus IH cross dou by dou X. So we have to find P square. P square means this term square minus IH cross dou by dou X whole square. That is P square is equal to minus into minus positive, I into I square means minus 1, H cut into H cut square, dou by dou X into dou by dou X, dou square by dou X square. Clear? So P square is equal to minus H cut square dou square by dou X square. So what will be this equation? Instead of E, I am going to substitute IH cross dou by dou T. IH cross dou by dou T, and the remaining psi here, IH cross dou psi by dou T, which is equal to we have a by 2m, that is by 2m, and what is P square? Minus H cut square dou square by dou X square, that is minus H cut square dou square by dou X square, and remaining we have a psi here, so dou square psi by dou X square, minus H cut square by 2m dou square psi by dou X square plus V psi. So we are substituting for E as well as P square in this equation. So this is our Schrodinger's time dependent one-dimensional wave equation. IH cross dou psi by dou T is equal to minus H square by 2m dou square psi by dou X square plus V psi. It is time dependent wave equation because it involves the term time here, right? So that it is known as Schrodinger's time dependent wave equation, and it is a one-dimensional wave equation because it involves only the variable x here, so that we can say that it is a one-dimensional wave equation. Now what will be three-dimensional case? IH cross dou psi by dou T is equal to minus H square by 2m. Instead of x square, we have to write dou square psi by dou X square plus dou square psi by dou Y square plus dou square psi by dou Z square. We have to consider x, y as well as z in the case of three-dimensional wave. Okay, plus V psi. IH cross dou psi by dou T is equal to minus H square by 2m. This term can be written as del square psi. It's an operator, del operator. So this is known as del square psi plus V psi, where del is equal to dou by dou X plus dou by dou Y plus dou by dou Z. This operator is known as del operator. So what will be del square? Dou square by dou X square plus dou square by dou Y square plus dou square by dou Z square. So we have a del operator here. Look this equation. Dou square by dou X square plus dou square by dou Y square plus dou square by dou Z square. Del square, a common factor psi. So del square psi plus V psi. Del square acting on the wave function psi. So this is our three-dimensional wave equation. So this one is one-dimensional Schrodinger's time-dependent wave equation, and this is the our three-dimensional wave equation.